Today's topic is motion word problems. And we're going to be using a formula to solve these, which is distance equals rate times time. Now, rate can mean many things. Rate, in this case, in most cases, is going to be speed. Okay? Speed is the rate of how fast we're going. So distance equals rate or speed times time. So if I'm going 60 miles per hour for 1 hour, I go 60 times 1, I go 60 miles. If I'm going 50 miles per hour for 3 hours, I can multiply 50 times 3, and I would figure out that I've gone 150 miles. So it's a pretty simple equation, right? We're just taking our speed times our time to get the distance that we've traveled. But it's going to let us solve weird problems like this. And I'm going to show you Gary's method for solving these problems, which uses a table, kind of a graphic organizer. And in this table, we're pretty much always going to have 3 columns. And the columns are going to be rate, time, and distance. And then we're usually going to have a couple of rows. And in this case, we kind of have 3 rows. We have train A, train B, and then we'll also, for some things, we'll have a total. Now, it doesn't really make sense to have a total rate in most cases, so we're not really going to use that. But we will want to know the total amount of distance. And in some cases, we'll want to know the total amount of time. In this problem, the trains leave at the same time, so the total amount of time doesn't really make sense in this particular problem. Okay. So in this case, we're just looking at a total distance. So if we read this problem, which I think you guys already did as you wrote it down, 2 trains leave the station at the same time, traveling in opposite directions. Train A is traveling 125 miles per hour. Train B is going 120 miles per hour. After how long will they be 735 miles apart? So we know how to solve problems as long as we only have one variable. Right? You can solve any equation that has, well, not any equation. You can solve most equations that have one variable in them. So our job here is really to figure out, okay, what is going to be our one variable? Because if we can get this down to one variable, then we can solve it.
Would it be h, like per hour?
Yeah, so our variable in this case is time. And we could use h for hours or t for time, whatever you want to use. And the key is that we don't know the time that this train has traveled. So I'll use h. I love that idea. But what do we know? If the train's left at the same time, train A's time and train B's time would be the same, right? They've been traveling for the same number of hours. So h would be the time for both train A and train B in this problem. If one of them left 2 hours earlier, we'd have to say like h and h minus 2. Right? But in this case, they left at the same time. So our variable is time. Now, what else do we know, though? We do know some information. We know how fast they're going. We know the rate. So train A and train B both have a rate in this problem. Where would I put that in my table, my sort of organizer? Yeah, under here. So what would I write in this box? 125. And I'm ignoring the units for now. And in this box, 120. Now here's the key step. Here's where I think this table really helps us. what is the distance? Well, the distance is just the rate times the time. So I'm just going to take 125 times h and put it in this box. So my distance for train A is 125h. My distance for train B is 120h. So the distance column is often going to just be multiplying the other two columns. And this is where the total box is important. I also know the total distance. I want their total distance apart to be 735 miles. Now let's think about what that means. Our trains started in the same spot, right? One of them went this way, and one of them went this way, opposite directions. So the total distance is this distance plus this distance, which is exactly how far apart the two trains are. Does that make sense? The total distance is the distance this train went plus the distance this train went. And since they went in opposite directions, the total distance is how far apart those trains are. Okay? If they had gone in the same direction, the total distance wouldn't really mean very much. If they had gone at 90-degree angles, we'd have like a triangle and we'd have to figure out how far apart they were in that triangle. But since they went in exactly opposite directions, the distance that they both went is how far apart they are. Okay? So this type of problem is like a total distance problem. This is kind of the key word. Apart, right? How long will they be 735 miles apart? We're not always going to be looking for this. All right. So now the key is to recognize that the total distance, right, 735, is equal to the distance of train A plus the distance of train B. So 735 is equal to 125h plus 120h. And now we actually have an equation that we can solve. So 735 is equal to what? 125h plus 120h is 245h. How do I solve for h? Just divide both sides by 245. And h equals 3. We can always check our work. We could say, okay, 735 divided by 245 on my calculator, it's 3. H equals 3. Okay, that's an answer, but it's not a very good answer, right? They said, after how long will they be 735 miles apart?
3 hours?
Yeah, after 3 hours. So I want to answer this sentence with like an answer that actually makes sense. So my final answer would be something like this. After 3 hours. After 3 hours. And I could kind of check that by saying, okay, after 3 hours, train A will have gone 3 times 125, which is 375 miles. Train B will have gone 3 times 120, which is 360 miles. 375 plus 360, they went in opposite directions. That's a total of 735 miles that they've come. That's how far apart they would be. Alright. So using this same kind of method, we can actually solve a whole bunch of different types of problems. So that's what we're going to do now. Alright, so let's take a look at another one. Nate and Gary live 810 miles apart. They both have very long commutes. If they leave at the same time, and drive toward each other, with Nate driving 55 miles per hour. I like to go the speed limit. And Gary, he's a little bit of a speed demon. He's going 80 miles per hour. After how many hours? I'm going to set up my chart. So rate times time equals distance. Those are my three columns. I'm going to have Nate, I'm going to have Gary, and then I'm going to have a total. We're leaving at the same time, so the total time doesn't really matter. Total rate never really makes sense. And now I can start to fill in this chart. So what kind of information on here do you see that might help us fill in this chart? Okay, so where would that go? Okay, so what would I write here?
55.
Nate is going 55. Gary's going 80. And I'm noticing as I'm doing this, okay, miles per hour, miles. I have all the same units, right? If I had like miles per hour, and then I had like how many, kilometers apart, I'd have to do a conversion first, right? I'm not going to give you problems like that for now, but it's important to pay attention to that kind of stuff. All right, what else do I know?
They both leave at the same time.
They leave at the same time. So what does that mean?
So it's times H.
Yeah, the time is the same variable, so we could use H again. Okay. Oh, now I've got rate and time, so I know distance now, right?
So it's 50.
Distance for Nate is 55H. Distance for Gary is 80H.
Wait, is this supposed to equal 180?
Yeah, not 180, but 810. Yeah, the total distance that we have to travel is 810 miles together. Because in this case, I'm starting over here, Gary's starting over here, we're driving towards each other. We don't know where we'll meet, but we know that we'll meet when the distance that Gary's gone plus the distance that I've gone is equal to 810 miles. Does that make sense? I don't really know how far Gary will have gone, and I don't really know how far I will have gone. And also the problem's not asking me for that. But I do know that together, if we added our distances together, we have to total up to 810 miles. Because that's how far apart we started. It's kind of like the reverse of the first problem. Right? In the first problem, we're starting together and figuring out how far we went total apart. In this problem, we're starting apart. We know how far we have to go total to meet together. So the problem is really, really similar. The setup is very similar to the last one. The total distance is just our distances combined. So again, I just solved this by doing what? Yeah, I know that total has to be this plus this, right? This plus this has to equal the total. So 55H plus 80H has to equal 810. Okay, what does that give me? If I add those up, 135H has to equal 810. Divide both sides by 135. I think that's like 6. Okay. 6. H equals 6. That's not a good answer though, right? How do I answer this problem? Yeah, at the very least I have to say something like after 6 hours. Eventually, Gary and I just decided it'd be easier for both of us to live in Santa Fe so that we wouldn't have to drive 6 hours every day. But it took us a little bit. That's why this kind of word problem is really useful. You have to figure out like, oh, we're driving 6 hours every day. If we just lived closer together, we wouldn't have to drive 6 hours. But if we didn't know how to do math, we never would have figured that out. So luckily, we're both math. All right, questions on this one? Very similar setup. Okay, let's do one that's a little different. All right. All right. Plane A leaves the airport flying east. I don't think I'm supposed to capitalize east, but I did. At 400 miles per hour. Plane B leaves the same airport going the same direction two hours later, traveling 600 miles per hour. How long will it take plane B to catch up? This is a slightly different problem. I'm no longer looking at planes going in different directions or starting apart. Now, if I were to kind of diagram out what's happening, I have one plane that leaves, right? And I have another plane that leaves, and I want to know when are they at the same spot. The difference is that this one is left earlier. right? One of the planes left the airport a little bit earlier. So is it traveling for more time or less time? It's traveling for more time, right? The plane that left earlier has more time to travel. We can still use our same chart though to solve this. Rate times time equals distance. Okay, plane A and plane B. Now in this case, I actually don't really need a total. I don't really need the total row. Because I don't know the total distance. I don't know the total time. But I'm going to have to kind of do a little bit of math in my head to figure out how to fill this chart in. The first thing is usually the easiest, right, is this rate column. In this case, again, this is the easiest part. I know that plane A is going 400 and plane B is going 600. The time here is tricky, though, because they're not going the same time, right?
So it's just H and H minus 2.
Yeah, there's two ways of solving this. If plane A has gone for H, then plane B has gone for H minus 2, right? Because it's gone less time. Plane B has gone for less time. The other way I could do it, and I would get the same answer in the end.
Is A could be H plus.
Yeah, this could be H and this could be H plus 2. Now, which way do you think I want to do it? What are they asking me to solve for?
Well, why don't plane B catch up?
Yeah. So I really want to know, after plane B leaves, how long will it take it to catch up with plane A, right? So I really want H to be plane B's time, because that's my answer, right? That's what I want to get as my answer. So I really want to set the problem up this way so that when I find H, I'm done. If I set it up the other way, there's one last final step where I have to say, oh, wait, but plane B went for 2 hours less. So I have to do that like H minus 2 at the end. So usually you're going to want to set it up so that your variable is the actual answer you're looking for, which in this case is how long will it take B to catch up. So B is H, which makes A 2 hours more than H. It's been going 2 hours longer. The distance column we're always pretty much going to do in the same way. I just take my rate times my time. So here I have 400 times H plus 2. And here I have 600H. I don't know the total distance, though. So how am I going to write an equation?
Is it kind of like one of those tables where you like put in the distance, like at the original hour?
We could. That's another way of solving this. There's a way to solve this algebraically. Let's think about it. If the planes have caught up, what do we know about plane A's distance and plane B's distance?
They're the same.
They're the same. Wait, so you're telling me that plane A's distance is the same as plane B's distance?
Yeah, so basically the equation is just 400 H times H plus 2 equals 600.
Yeah. I'm looking for the time when these two things are equal to each other. Now I have to use the distributive property to solve this one. 400H plus 800 equals 600H. So this is like my little diagram. I'm going to erase that. The next step that I would do here is subtracting 400H from both sides. Now I have 800 equals 200H. And we can just divide So then I get 4 equals h. Okay, I have an answer, but that doesn't make any sense. How long will it take plane B to catch up?
It will take
4 equals h.
It will take 4 hours.
It will take 4 hours. And I'm going to kind of make sure that that really makes sense, right? Is h really the time that I'm looking for? Yeah, that's plane B's time. The other thing I could do is I could kind of quickly say, okay, well if h is 4, then this is 6, and I could figure out, oh, 400 times 6 is the same as 600 times 4. So that's when they will catch up. All right. Questions on these? Let's do some practice. I think that the hardest part of these for you guys today is going to be just figuring out which type of problem